Dear students, in this video, we present a suggested exercise for the first term exam for grade 12 students in mathematics. We will cover logarithmic equations and inequalities. For each question, there is only one correct answer among the three proposed choices. Identify it with justification. Question 1. The solution set for the inequality. 6 plus e to the power of 2x is less than 5 times e to the power of x in the set of real numbers is option A, the open interval from the natural log of 2 to the natural log of 3. Option B, the open interval from 2 to 3. Option C, from negative infinity to the natural log of 2, union the natural log of 3 to positive infinity. Question 2. The solution set for the inequality, the natural log of the natural log of the natural log of x is greater than 0, is option A, the interval from e to positive infinity. Option B, the interval from e to the power of e to positive infinity. Option C, the interval from e cubed to positive infinity. 3. The numerical function f defined on the set of real numbers by f of x equals the natural logarithm of x plus the square root of x squared plus 1. We have a. F of 1 minus x equals f of x. B. F of negative x equals f of x. C. F of negative x equals negative f of x. Question 4. The particular solution to the differential equation y prime plus y plus 1 equals 0, where y of the natural logarithm of 2 equals 0, is a. G of x equals negative 1 minus 2e to the power of negative x. B. G of x equals negative 1 plus 2e to the power of negative x. C. G of x equals e to the power of x minus 2. 5. The function h of x equals 1 over the natural logarithm of x plus the natural logarithm of the natural logarithm of x, and it is differentiable on the open interval from 1 to positive infinity. Its derivative is a. H prime of x equals 1 minus the natural logarithm of x, all divided by x squared times the natural logarithm squared of x. B. H prime of x equals 1 minus the natural logarithm of x, all divided by x times the natural logarithm squared of x. C. H prime of x equals negative 1 plus the natural logarithm of x, all divided by x times the natural logarithm squared of x. 6. The function k of x equals x times the quantity e to the power of x minus 1 divided by e to the power of x plus 1 times the sign of x satisfies a. Negative x plus k of x equals 0. B. K of negative x minus k of x equals 0. C. K of negative x plus k of x equals x times the sign of x. Solution. To determine the solutions for this inequality, we perform a change of variable. We let t equal e to the power of x. Since the exponential function is always positive, we only consider solutions where t is greater than 0. The inequality becomes 6 plus t squared is less than 5t. This is equivalent to t squared minus 5t plus 6 is less than 0. We calculate the discriminant, delta. We find that it equals 1. The roots are t1 equals 2 and t2 equals 3. For the expression to be less than 0, t must be between the two roots, meaning between 2 and 3. We return to the original variable. Since t is e to the power of x, then e to the power of x is between 2 and 3. By applying the natural logarithm to the sides, we find that x belongs to the open interval from the natural log of 2 to the natural log of 3. The correct answer is option A. While waiting to continue the video, don't forget to subscribe, like, and share the video, as well as leave comments. To solve the inequality, the natural log of the natural log of the natural log of x is greater than 0. First, we determine the domain of definition. The value inside the logarithm must be positive. Working progressively, we find that x must be greater than e. To solve the inequality, we say that what is inside the first logarithm must be greater than 1, meaning the natural log of the natural log of x is greater than 1. This is equivalent to the natural log of x is greater than e to the power of 1. Finally, this is equivalent to x being greater than e to the power of e. Therefore, the correct answer is option B. We study the parity of the function f. We calculate f of negative x. We find that it equals the natural log of negative x plus the square root of negative x squared plus 1. We multiply by the conjugate to simplify the expression. After simplifying, we find that it equals the natural log of 1 over the quantity x plus the square root. Using the properties of logarithms, this equals the negative natural log of the original expression, meaning f of negative x equals negative f of x. Therefore, the function is odd, and the correct answer is option C. While waiting to continue the video, don't forget to subscribe, like, and share the video, as well as leave comments. Question 4. The particular solution to the differential equation y prime plus y plus 1 equals 0, where y, evaluated at the natural log of 2 equals 0, is a. g of x equals negative 1 minus 2 times e to the power of negative x, b. g of x equals negative 1 plus 2 times e to the power of negative x, c. g of x equals e to the power of x minus 2. So, to verify this relationship, meaning the differential equation relationship, we will take g of x for each option individually. So, I have a. Let us take g of x equals negative 1 minus 2 times e to the power of negative x and differentiate it. Y prime is the derivative of g of x. So, g prime of x equals the derivative of negative 1 is 0. The derivative of negative 2 times e to the power of negative x is negative 2 times the derivative of e to the power of negative x. The derivative of e to the power of negative x is negative e to the power of negative x, which equals negative times negative gives us a positive, so positive 2 times e to the power of negative x. Now, let us verify the relationship g prime of x plus g of x plus 1. Does it equal 0? We have g equal to negative 1 minus 2 times e to the power of negative x, and g prime is positive 2 times e to the power of negative x plus 1. I have negative 2 times e to the power of negative x plus positive 2 times e to the power of negative x, which gives us 0. Negative 1 plus 1 gives us 0. So, the first relationship is satisfied. Now, let us verify the second relationship, which is g of the natural log of 2 equals negative 1 minus 2 times e to the power of negative natural log of 2. What does it equal? Negative 1 minus 2 multiplied by, to handle the natural log here, meaning to remove the minus from the outside so it can be cancelled with the exponential. We take the minus sign and move it inside the natural log. Inside the natural log, it becomes 2 to the power of negative 1. So I have negative 1 minus 2 multiplied by e to the power of the natural log of 2 to the power of negative 1. Here, the natural log cancels out with the exponential, leaving me with negative 1 minus 2 multiplied by 2 to the power of negative 1, which equals negative 1 minus 2 divided by 2. That gives us negative 1 minus 1, which equals negative 2. This is different from 0. So the second relationship is not satisfied, and consequently, this is not a solution to the differential equation y prime plus y plus 1 equals 0, such that y of the natural log of 2 equals 0. b g of x equals negative 1 plus 2 times e to the power of negative x. The derivative g prime of x equals, the derivative of negative 1 is always 0. Positive 2 times e to the power of negative x gives us 2 multiplied by the derivative of e to the power of negative x, which is negative e to the power of negative x. So it becomes negative 2 times e to the power of negative x. G prime of x plus g of x plus 1. Let us verify this relationship. What does it equal? G of x is negative 1 plus 2 times e to the power of negative x. G prime of x is negative 2 times e to the power of negative x plus 1. So we have negative 1 canceling out with positive 1, and positive 2 times e to the power of negative x canceling out with negative 2 times e to the power of negative x. Therefore, it equals 0. So the first relationship is satisfied. The second relationship. What does g of the natural log of 2 equal? Negative 1 plus 2 times e to the power of negative natural log of 2. We substitute x with the natural log of 2, which equals negative 1 plus 2 multiplied by e to the power of the natural log of 2 to the power of negative 1. Just like before, we moved the negative 1 inside the natural log, becoming 2 to the power of negative 1. So, the natural log cancels with the exponential, leaving me with only negative 1 plus 2 multiplied by 2 to the power of negative 1, which is negative 1 plus 2 divided by 2, becoming negative 1 plus 1, which equals 0. Consequently, the second relationship is satisfied. Therefore, this solution satisfies both relationships and is indeed the solution to the differential equation. We are left with the final question. C. G of x equals e to the power of x minus 2. G prime of x equals e to the power of x, because the derivative of negative 2 is 0. So we substitute into the equation y prime plus y plus 1. It becomes g prime of x plus g of x plus 1 equals what? G prime of x is e to the power of x. G of x is e to the power of x minus 2. So here, this gives us 2 times e to the power of x minus 1. This differs from 0. So this solution is rejected. And finally, the particular solution for the differential equation y prime plus y plus 1 equals 0, where y of the natural log of 2 equals 0, is what? It is g of x equals negative 1 plus 2 times e to the power of negative x. The function h of x equals 1 divided by the natural log of x plus the natural log of the natural log of x is differentiable on the interval from 1 to plus infinity. Its derivative is option A, h prime of x equals 1 minus the natural log of x divided by x times the natural log squared of x. Option B, h prime of x equals 1 minus the natural log of x divided by x times the natural log squared of x. Option C, h prime of x equals negative 1 plus the natural log of x divided by x times the natural log squared of x. So let us take the function h of x equals 1 divided by the natural log of x plus the natural log of the natural log of x and differentiate it. First, we have 1 divided by the natural log of x, which equals the natural log of x raised to the power of negative 1. We differentiate this function. The derivative of the natural log of x raised to negative 1 is negative 1, which is the exponent, multiplied by the natural log of x, the term inside the parentheses, raised to the power of negative 2. This is because negative 1 minus 1 equals negative 2. This is then multiplied by the derivative of the natural log of x. This equals, since the exponent is negative 2, the natural log of x moves to the denominator and becomes squared. It becomes negative 1 divided by the natural log squared of x multiplied by the derivative of the natural log of x, which is 1 divided by x. This gives us negative 1 divided by x times the natural log squared of x. Now, let us take the natural log of the natural log of x. We change the variable. We set the natural log of x equal to capital X. The derivative of the natural log of the natural log of x is equal to the derivative of what is inside, meaning capital X prime, multiplied by the derivative of the natural log of capital X, which is 1 divided by capital X. And what does that become? Capital X prime is the derivative of the natural log of x, which is 1 divided by x. And 1 over capital X is 1 divided by the natural log of x. So it equals 1 divided by x multiplied by 1 divided by the natural log of x, which equals 1 divided by x times the natural log of x. Therefore, h prime of x equals negative 1 divided by x times the natural log squared of x, which is the first derivative we found, plus 1 divided by x times the natural log of x. We find a common denominator. We have negative 1 here, which stays in the numerator over the denominator x times the natural log squared of x, which remains the same. Over here, we have x times the natural log of x. To make the denominator x times the natural log squared of x, we must multiply the numerator by the natural log of x. The final result is h prime of x equals negative 1 plus the natural log of x divided by x times the natural log squared of x. While waiting to continue the video, don't forget to subscribe, like, and share the video, as well as leave comments. Question 6. The function k of x equals x times the quantity e to the power of x minus 1 divided by e to the power of x plus 1, all multiplied by the sign of x. It satisfies the following relations. A. k of negative x plus k of x equals 0. B. K of negative x minus k of x equals 0. C. K of negative x plus k of x equals x times sine of x. So here we will calculate both k of x and k of negative x, then we will add them and verify the equality found in option A. Let's start. We have k of x defined as x times the fraction e to the x minus 1 over e to the x plus 1 times sine of x. For k of negative x, we substitute negative x in place of x. It becomes negative x times the fraction e to the negative x minus 1 over e to the negative x plus 1, all multiplied by sine of negative x. From the properties of sine, we know that sine of negative x is equal to negative sine of x. The negative sign moves to the outside. So k of negative x becomes negative x times the fraction e to the negative x minus 1 over e to the negative x plus 1 times negative sine of x. The negative times the negative cancels out, becoming positive. Consequently, it equals positive x times the fraction e to the negative x minus 1 over e to the negative x plus 1 times sine of x. Here, to transform the fraction containing e to the negative x, so we can compare it to the original term, meaning the fraction e to the x minus 1 over e to the x plus 1, we multiply both the numerator and denominator of the fraction by e to the power of x. Since we're multiplying the top and bottom by the same value, the value of the fraction remains the same. It becomes e to the x times e to the negative x is 1, since e to the power of x minus x gives us e to the 0, which is 1, minus, we multiply the 1 by e to the x, which gives us negative e to the x, and on the bottom, e to the negative x plus 1 multiplied by e to the x also gives us 1 plus e to the x. Substituting this back into the equation for k of negative x, I get k of negative x equals x times the fraction 1 minus e to the x over 1 plus e to the x, multiplied by sine of x. And for the original k of x, we have x times the fraction e to the x minus 1 over e to the x plus 1 multiplied by sine of x. Therefore, what does k of x plus k of negative x equal? It is x times sine of x multiplied by the sum of the two fractions, e to the x minus 1 over e to the x plus 1, plus 1 minus e to the x over 1 plus e to the x. What does this equal? We have a common denominator here, e to the x plus 1. So it becomes x times sine of x multiplied by the numerator, e to the x minus 1 plus 1 minus e to the x all over e to the x plus 1. So, positive e to the x cancels out with negative e to the x, and negative 1 cancels out with positive 1. I am left with x times sine of x multiplied by 0 divided by e to the x plus 1, which equals 0. Consequently, the first relationship is the one that is satisfied. K of x plus k of negative x equals 0. And finally, my dear students, I thank you for your attention. Until next time, peace be upon you, and the mercy and blessings of God.